Today we are going to discuss variation of acceleration due to gravity with height. Now we have got gravity is the force of attraction between Earth and some other body, and on the surface of Earth the value of acceleration due to gravity is gme divided by re square, and its value is 9.81 meters per second square approximately. Now let's consider a body at a height h as is shown in the figure. The mass of the body is m. So we have written consider a body of mass m at height h from the surface of Earth as shown in the figure. The force of attraction between m and me, the force of attraction between this body m and me is the mass of the Earth. That is given by the universal law of gravitation as follows: F is equal to g m divided by r square, where m is the mass of Earth and r is the distance between the center of the Earth and the center of the body. Since universal law of gravitation says F is equal to g m1 m2 divided by r square. Now in this case the distance between their centers is re plus h. The distance between their centers is re plus h. Re is the radius of Earth and h is the height from the surface of Earth. Then F is equal to g m divided by re plus h whole square. Now F is equal to g m. We can take re as common. Then inside we will have h plus 1 plus h by re whole square. Now giving square to both re and 1 plus h by re, we will get g m divided by re square to 1 plus h by re the whole square. Then we can have F is equal to gme by re square. This 1 plus h by re whole square in the denominator can be taken to the numerator with the power as -2. So we will have 1 plus h by re raised to power -2 using binomial theorem, which says that a plus b raised to power n is equal to a raised to power n plus n into a raised to power n minus 1b plus n into n minus 1 divided by 2 factorial a raised to power n minus 2b square, so on and so forth, to b raised to power n. Now the higher terms in this will get cancelled because we will have the h by re raised to power 2, h by re raised to power 3, h by re raised to power 4. Since re is very larger than h, so h by re will be very small. So the higher powers of h by re will get neglected. That's why I wrote the only two terms of the expansion. That's a raised to power n plus n into a raised to power n minus 1 into b. Here I will get the value of gme by re square into 1 minus 1 raised to power anything is 1. 1 raised to power negative is also 1. 1 raised to power 0 is also 1. 1 raised to power minus 2 is also 1. That's why here it's 1. Minus plus minus 2. 1 raised to power minus 3 is again 1. H by re. So that is 1 minus 2 into h by re. But we know that this gme divided by re square is equal to the small g, that's acceleration on the surface of Earth. So our final expression will be F is equal to g, that's acceleration on the surface of Earth, into 1. Sorry, it's here. F into what is the m? I forgot to write m here. M. So we have F is equal to mg into 1 minus mg into 1 minus 2h by re. So we can have from, since F is equal to ma from second law of motion, so we will have F is equal to mg dash, where g dash is the acceleration due to gravity at height h. So combining this first and second, so we can say from first and second, mg dash is equal to mg into 1 minus 2h by re. It implies m and m will get cancelled, so g dash is equal to g into 1 minus 2h by re. That's the expression for acceleration due to gravity at height h when h is less or smaller than re. That's all.